Welcome back, my dears. This is the second video for chapter 14, section 1, properties of acids and bases. In this video we'll talk about the two topics. The first one is the Arrhenius acids and bases, and the second topic is about the strengths of the acids and bases. Firstly, let's know what's the meaning of, or what is the Arrhenius acids and bases. An Arrhenius acid is a chemical compound that increases the concentration of hydrogen ion H positive in an aqueous solution. And for the Arrhenius base is the substance that increases the concentration of hydroxide ions OH negative in aqueous solutions. Let's dig more deeper. The Arrhenius acids are molecular compounds with ionizable hydrogen atoms. Their water solutions are known as aqueous acids. This is an example which will explain what we have said in the previous slide and this one. This is an acid which is the nitric acid HNO3, which is, as we said, a molecular compound, so it's forming ions when it reacts with water H2O, so it gives the hydronium ion we said before in the previous chapter, and that the hydrogen do not stay at the same, but it directly reacts with water to form the hydronium ion, so it is a hydronium ion, and then it will leave the nitrate ion as we said here. So since it's have ions in the water, so it's our electrolyte. This is some common types of aqueous acids, which will be categorized to strong acids and weak acids. So here is a question: how we can say this acid is a strong acid and this acid is a weak acid? To know the answer, let's move to the next slide. A strong acid is the one that ionizes completely in aqueous solution. Strong acid, so, is a strong electrolyte because it ionizes completely in aqueous solution. We have three examples, and you may know more than of this. We have the perchloric acid and HCl and HNO3, which is the nitric acid. And for a weak acid, it's the release few hydrogen ions in aqueous solution, so it gives here for strong acid a lot of hydrogen, and here it gives a few amount of hydrogen ions. Example is HCN, which is the hydrocyanic acid. Hydronium ions anions and dissolve with acid molecules or in aqueous solutions, unlike here. In a strong acid there is only ions. And another example for weak acids, the organic acids, which is end with COOH, like the acetic acid, which have the formula of CH3COOH. Now we will move to the bases. Most bases are ionic compounds. They containing metal cations and the hydroxide anion, metal cation and hydroxide anion. It dissociates in water, like we said before in the previous chapter. Since they are ionic, so they can dissociate in water. An example is NaOH solid, which dissociates in water to give Na plus aqueous, which is the sodium ion, and OH negative aqueous, which is the hydroxide ion. Okay, and another example, so we said most of bases, not all of them are ionic. So some of them, like ammonia and NH3, is a molecular. So ammonia produces hydroxide ions, but when it reacts with water molecules, so NH3 aqueous plus H2O liquid, it gives NH4 ammonium ion aqueous, positively charged, and OH negative aqueous, which is the hydroxide ion. So it's a base. Okay, when we deal about, or when we talk about the strengths of the bases, the strengths of the bases depend on the extent which the base dissociates to give hydroxide ion. Yes. Okay, so we have some examples here, like CaOH OH2, which gives calcium ion, and 2OH ion. Okay, and weak bases which have NH3 reacts with H2O to give NH4 positive ion plus OH negative. So it depends on how many hydroxide ion it gives while it dissociates or ionizes according its a molecular or ionic compound in water. So we finished what we need to know here in this section. So let's move to the questions. This is your worksheet labeled like this, chapter 14, section 1, properties of acids and bases. We will move on the first page questions to check that we are understanding well what we have studied. A strong acid A ionizes completely in a solution. B produces hydronium ions in a solution. C reacts with metal that are active, that are more active than hydrogen. And D is all of the above. Your answer? Yeah, it's all of the above. D. 2. When a solution of a hydrochloric acid HCl reacts with zinc, which of the following substance is a reactant? A. Cl negative, B. H positive, C. H3O, D. H2O. Take care, it is a acid HCl react with zinc, which is a metal. The answer is C, H3O. 3. Which of the following characteristics describe a base? A. It reacts with oils in the skin and converts them to acids. B. Forms alkaline solutions. C. Is a non-electrolyte. D. None of the above. The answer is B. It forms alkaline solutions. 4. Which of the following substance is a weak base? NH3, KOH, K2O, NOH. Weak base. It's NH3. 5. Strong acids are A. Strong electrolytes, B. Weak electrolytes, C. Non-electrolytes, D. Non-ionized. The answer is yes, strong electrolytes. Okay, now is number 6. Hydroxides of group 1 metals are all strong bases, are all weak bases, are all acids, do not dissociate in a solution. The answer is A, are all strong bases like NaOH, KOH, and so on. So let's move to the page number 2. 7. Strong bases are A. Strong electrolytes, B. Weak electrolytes, C. Non-electrolytes, D. Also strong acids. The answer, strong bases. Strong bases, so it's dissociates or ionized very well, so it says strong electrolytes. The answer is A, strong electrolytes. 8. Which of the following is not a strong acid? HCl, H2SO4, CH3COOH, HPR. Not a strong acid. Not, so it's mean it's a weak. We have a very common weak acid, which is the CH3COH, so the answer is C. 9. A highly polar molecule that contains a weak bond between a hydrogen atom and another element would be A. A weak acid, B. Unable to ionize completely, C. A non-electrolyte, D. A strong acid. Contain a weak bond between a hydrogen atom and another element. So when we are talking about a weak bond, so it will dissociate well, yeah, so it's a weak or strong acid. Yeah, exactly, it's a strong acid, D. So now the last but not least, 10. An Arrhenius acid is a chemical compound that A. does not conduct electricity, B. increase the concentration of H positive ions in a solution, C. reacts with the water to remove H positive ions, D. dissociates to release OH ions in a solution. Your answer? Yes, it increases the concentration of H positive ions in a solution. For this we have already answered it, except E, hydrogen cyanide, which have the formula of HCN. So its name will be hydrocyanic acid. So let's move to number 2. Which if any of the acids mentioned in item 1 are primary acids? The answer is C, only H2S. Thank you for watching and hope you are enjoyed in this video and you understand each point we have dealt with very well. Thank you again and be safe.